guys. This is week 11, I think. You've already had a few lessons, so it's not really the first lesson of the week. But today we're going to have a lesson on, we're going to do the challenging question in page 172. Now, let me just tell you already now, okay, these questions are really difficult. And I wouldn't stress too much about them. And if I were you personally, I would even consider not even listening to this video, so you can just stop me now. But before you stop, instead of doing nothing, don't have to listen to this video, but instead revise for the test that's happening this week on Thursday, which is going to be about congruency, similarity, and a probability. Okay, so it's chapters. Just to read that to you here. Okay, just hang on. Yeah, so it's chapter 11, 12, and 20. Okay, so you've got probability there, and then you've got 2D shapes. So you need to know all about angles and quadrilaterals and parallel line, but also similarity and congruency. Okay, so what I'm doing now is difficult question, and there will be at least one difficult question, but it is really more important that you get the basic stuff. Basic level question, and then the intermediate, high end is not a big disaster if you don't. Okay, anyway, I'm going to do question A. I'll start with A in page 172. And the first bit, we're given this parallelogram, so this parallel to that, that parallel to that. We also told that these three sides are equal. We told that this is 60 degrees, and this is 2x, and we want to find x. Okay? Right, how do we do it? First clue is to see, okay, let's look at this triangle, ABE. If this is 60 degrees, angle B, okay, angle B is also 60 degrees, okay, because it's equal angles, opposite, equal sides. Okay, so these two angles must be the same because the sides are the same. So this is 60. Now, if this is 60 and this is 60, then A1, if you add to 60 plus 60 in this triangle, have to be 180. Sum of angles, I'm not going to finish, sum of angles in a line. Okay, so A1, if you do the maths, comes out as 60 as well. So if this is 60 as well, then this is the equiangular triangle. And an equiangular triangle means that all the sides are equal. Okay, so triangle, therefore triangle ABE is equiangular, and therefore all the sides are the same. So BE is equal to AB equal AE. Okay? You have a triangle with 60 degrees, all angles are 60 degrees, meaning all the sides are the same. Right, why I do that? Yes, now AB, okay, must be equal to CD. Okay? CD is equal to AB, okay, because it's a parallelogram, or more accurate, opposite sides in a parallelogram. So what we get is situation is that DC equal EC. Okay, so this is a triangle and it's isosceles. The sides are equal. Now in isosceles, and why is this going to help me? Right, we're not finished. Actually, I didn't even need to do that. Didn't even need to go there. Not really at this point. I will need it later. But what I know about 2x and 60, once I know this is 60, could have gone straight from here, but never mind. Okay, so if this is 60, okay, 2x plus 60 must be 180 because cointerior angles, angles, and we need to mention the lines that are parallel, AB parallel to CD. Okay, so from here I can find out that 2x is 120 and x is 60. So really, guys, I took you a bit of a detour here, but as soon as I found that B is 60, okay, from here I could have just gone straight to there. I didn't really need all that bit, but I didn't erase it because I will need it later. Okay, so just to show what x is, I could have gone from here directly to there, but I will need this issue a bit later. Right, so the second bit they're asking me to find is E2. And for that, I need to find this angle. And for that reason, it is good that I did all this mission. Because if C, now I know that C is equal to x, 2 times 60, which is 120. So I know this is 120, right? We just found that 2x is 60, that means 2x is 120, okay? Now, I also proved that these two sides are equal, EC equal to CD, okay? EC equals CD, proved. Therefore, E3 is equal to D2. These two angles are the same, okay? I won't write it, but I won't write all of it, but it's equal angles, opposite, equal sides. So I also know that E3 plus D2 plus 120 is 180. Okay, sums of, I won't write the sum of angles in a triangle. And I know that E3 is equal to D2, so I can say that 2E3 plus 120 equal 180. So instead of D2, I wrote E3 because they're equal. You can still see that, yeah? And therefore, if you work out the maths, it works out that E3 is 30. Okay? So E3 is 30. Now, I won't write it because I kind of ran out of space. But you can see that 60 plus E2 plus 30 must be equal to 180, sum of angles in a triangle. And then if you write that down, okay, I'll write it down for you here. 60 plus 30 plus E2 is 180, sum of angles, not sum of angles, sorry, adjacent angles on the line. Yes, adjacent angle on the line. Then you can find out that E2 is 90 degrees. Okay, so we find that E2 is 90 degrees. Okay, so that is obviously a difficult question because you can see there's a lot of stages to do. But even, if you see something like that, if you can just prove something, it doesn't matter, okay? Each one of these lines, almost each one of these lines is a mark. So if you can get at least 1 or 2 marks, that will be fantastic. Right, let's move on to one more question. Okay, so this is another question with 2-dimensional shape, but this one is to do with congruency, okay? And there probably will be one question very similar to that. We like these kind of questions, and then they're tough, they're not easy. So we've got a triangle, and the first, this is, we are at the last question, not the last question, it's question E, okay? In page 173. Now, we're given this triangle, we're told that this is equal to that, this is equal to that, that's it. And they want us to prove that DB equal to EC. So if you look at this, look, you got to figure out which triangles you're trying to prove congruency, okay? And it just comes up with experience. If I want to show that these two sides are equal, and I can see this side is equal to that side, yeah, it's kind of obvious that the two triangles are this green one and the blue one. And again, I guess it's experience to be able to realize which triangle I'm trying to prove congruency. I want to prove that the green and the blue are congruent. I already see that these two sides are equal. Okay? So, but then it's also quite obvious to see that these two angles are equal. Okay, why are these two angles equal? Vertically opposite. Okay? So I need to give it letters. Okay, so there is a letter. So this is H1 and H2. Yeah. So I'll start with the hard one. So H1 equal H2, vertically opposite angles. Okay. Then I gotta say DH equal HE given, and HB equal HC given. Okay. So then we have to say the triangles are congruent, and I've got to be careful that the order will be right. Okay, so I'm going to write DHB. Okay, I went DHB, so therefore I'll have to have EHC, congruent to EHC. And don't forget, you got to write, is it SSS, ASS, SAA, all that stuff. Okay, we've got side, angle, sine, so it's SAS. You have to write it. If you don't write that, you will lose mark. Okay? Now, once we've proven that they're congruent, now I can say, okay, because these two triangles are congruent, then DB equal EC. Just draw it like that. Do these two arches. Therefore, DB congruent, or not congruent, equal to EC. And now this is a little bit funny. You got to give a reason. Okay, what is your reason? The reason is that these two triangles are congruent. DHB congruent EHS. You just have to say it. You have to rewrite it. It's because these triangles, we just proved that they're congruent, then the sides will be equal. Okay? So that is the first part they're asking you. Now they're asking us to prove another congruency, ABE and ACD. So they want us to prove that this triangle, ACD, okay, this green triangle, turn that into a black now, okay, is congruent to which triangle? Can you guess? It's to this triangle. ACD to ABE, yeah. Can't really, it's overlapping itself, okay? So this triangle equal congruent to this triangle. Okay, how am I going to do that? How am I going to do that? When if you're trying to prove congruency, first thing I would look is for things that are common, sides that are shared, side or angles that are shared by the same triangle. So we got triangle ACD and ABE. They obviously share the same angle. Okay, angle A is both in ABE and in ACD. So angle A is equal to itself because common. Okay. Right? Now can we think about another angle that is equal? Okay? There is another angle, and that's those two angles. I'll draw them as double. Okay? Okay? B1 equal to C1. Now why is that the case? Why are they equal? Okay? Well, they're equal because they're two angles in those triangles that I just proved that they're congruent, right? These small triangle congruent, that means these two angles are the same. So I need to write why, because triangle DHB, I'm just quoting that, is congruent to triangle EHC. Okay, so we've got two angles, 1, 2. Okay? Now I don't want another angle. What I would like is another side. Is there a side that is equal to each other? And the answer is yes. Okay? Look at the side BE and DC. They have to be equal. Why they have to be equal? Because BE is H and HE, and DC is DH and HC. But BH equal to CH and EB is equal to DH. You see? So this side is made out of this chunk and that chunk. This side is made out of this chunk and that chunk. And that one bit equal to that and that one equal to that. Okay, so how do we write it? I would write it like this. I would say, okay, DH equal HE given. And BH equal HC also given. Therefore, DH plus BH, if I'm adding those two, I'm going to also, that will be equal to HE plus HC. Okay, if that is equal to that, and that is equal to that, then those two together will be equal to those two together. But what is DH plus B? DH plus, oh, no, hang on. Okay, no, sorry, I didn't write them in the right order. Sorry, let's change it, okay? So DH equal HE, that's fine. Okay? And now I'm going to write HC is equal to BH, okay? I've done the same thing, I just moved them to the other side, okay? Now, what is DH plus, so that means, therefore, DH plus HC equal HE plus BH. What is DH plus HC? DH plus HC. Well, therefore, DH plus HC is DC. So DC is equal to, and what is HE plus BH? It's E. Okay? So now I've got three things. Look at this. I'll highlight for you. I've got an angle that is equal. I've got another angle that is equal. Okay, B1 and C1. And I've got a side that is equal. DC and BE. Therefore, I can say the triangle, okay, I'll be careful here, ABE is congruent to triangle ACD. And the reason is SAA. Okay? So as I told you guys, this is difficult stuff. Oh, we haven't even finished, okay? I'll just finish this by talking rather than writing. They're asking us to show that AB, side AB, is equal to AC. Now, they're asking two methods. Let's just do one. I just showed you that these two triangles are congruent. Therefore, the sides will be equal to each other. So it's just a one line. I just say that is equal to that. Why? Because these two triangles are congruent. That's it. Anyway, as I said, these two questions I just solved are difficult. Okay, these are the ones that we expect people get 90%, high 80% to be able to get them. If you don't get that, it's not the end of the, it's not a disaster. These are advanced questions. You guys got to make sure your basic question 100%. Intermediate question, you get as much as you can. And you will get one question like that in the test. If you can get 1 or 2 more, that's brilliant. Okay? So what I'd like you to do now is revise for chapter 11, 12, and 20. Probably the best way to do is go to the revision exercise at the end of these chapters and just do a few questions. If you feel like, you can also listen to some of the videos that I've had in the last few weeks. But obviously, if there's any problem, just send me on WhatsApp. Okay? Good luck in the test.